seemed like a really great idea at the time to write my slides in JavaScript, so that's what I did, and they might crash at any moment, so bear with me. So I'm Owen. I'm a product engineer here at Intercom. I've worked on a whole bunch of different parts of the product. So Intercom it's an interesting place to work. So we're all about. So what is Intercom? Intercom is all about communication and helping you better communicate with your customers. This is our homepage. Customer communication made simple. It's our mission. It's kind of what we're about. And one of the ways in which we enable you to communicate with your customers is via our in-app messenger. So this is our in-app messenger down on the bottom right of this screen here. And the in-app messenger, so we have this on the web. We also have it on mobile. And we support a bunch of other channels through which you can kind of communicate with your customers as well, like email and push messages. But this is what I'm going to be talking about this evening. And I think this is sort of interesting from the point of view of a bunch of JavaScript developers, because this is a JavaScript, client-side JavaScript application. It's actually a Backbone application. And it's a third-party client-side JavaScript application. Yeah. So my other messenger demo that I like to roll out is within Skylight. So if you're not familiar with Skylight, it's an application performance monitoring tool for Rails and Ruby applications. It's written in Ember by a bunch of the core Ember guys, and they're using Intercom, and so here's the messenger there. And I like to show this because this is a Backbone application running inside of an Ember application, which is kind of cool. So that's the in-app messenger. It's a really interesting part of the product for a bunch of different reasons, and it's actually kind of the idea that was sort of the spark for Intercom. So the founders of Intercom had a previous product, and they built this little messaging widget into that product that allowed them to sort of announce new features and get feedback. And that idea, that little thing within this product, was sort of the spark that led to Intercom. So Intercom, or the in-app messenger, has sort of been a cornerstone of Intercom ever since. That was 3 or so years ago. In the first sort of 2.5 years, we learned a lot about the product. We learned a lot about how people were using our in-app messenger, how they were talking to their users using it. We learned a lot of things from a sort of a technical point of view. The landscape of JavaScript development has changed dramatically in that time. So about 6 or so months ago, we sat down to kind of look at what we had in terms of the V1 in-app messenger, and look at what we wanted, both from a technical point of view and a product point of view. And we made the decision to sort of tear it down and rebuild it using a bunch of new tools and techniques. And so that was sort of a fascinating project. Rebuilding a kind of a core component of any product is challenging, but rebuilding a core component that is or has become an integral part of your customer's products is sort of doubly challenging. So it's kind of fascinating, and I'm going to talk about some of the technical challenges that we encountered. So I was sort of sitting down the other day thinking about, how could we sort of run through these technical challenges in hopefully a fun and not boring way. And I thought, well, maybe we could build a third-party JavaScript client-side application messaging widget thing in 20 minutes to sort of demonstrate some of those challenges. And so that's what I'm going to try to do in 20 minutes, is build Minicom, which is an Intercom competitor. So let's go. So this is Acme Corp. They do things on the internet, and they've got some problems. One of which is they don't have a really great way of communicating with their customers. They've got their phone number and address there, but that's not really working out very well for them. So they're our first customer. We're going to build them a messaging widget. So what is the MVP? Let's say that the MVP is JavaScript widget that they can install on their page, and it gets them a little contact link that their customers can click on, and it will open a widget, and they can use that widget to submit feedback or bug reports or whatever, and that's it. So, in another version of this talk, this little section about JavaScript was basically JavaScript is a language with a checkered past, but it's awesome, and this is why it's awesome. But you guys already think JavaScript is awesome. That's why you're here. So I'm just going to skip. So what we're talking about here is third-party JavaScript. So JavaScript development and development on the web is kind of a fascinating place to be a developer, because it's this sort of thing that you have to deal with on a daily basis. This idea that the browser can't be trusted. Things have gotten better in the last couple of years, but even today, browser vendors are sometimes not the greatest at interpreting specs or collaborating, and we end up with these sort of subtle differences and nuances in the way that browsers work, and we as developers have to kind of be aware of these things and work around them. And we've gotten, there's great tooling has sort of emerged over the last couple of years to help us with those differences, nuances, like jQuery and the like. But it's still it's an interesting place to be a developer. And as a developer of third-party JavaScript, so when I say third-party JavaScript, I mean JavaScript that you write that gets executed on somebody else's page. You're subject to this whole other set of interesting challenges, which is you're no longer just subject to the whims of the browser and the browser vendors. You're now also subject to the whims of the developer who behind the page that you're running on. So it's pretty interesting. So third-party JavaScript, JavaScript loaded from some third-party site that adds functionality to my page. As an example, this is the Facebook like button. You include this JavaScript on your page, and you have the ability to show a like button somewhere on your page. So as an example of the kind of crazy things that you encounter as a developer of third-party JavaScript, this is actually something that we came across in the wild that was leading to our messenger behaving in weird ways on this one site. I would love to meet the developer who wrote this and ask him or her why. But yeah, this is something that is possible to do in JavaScript. You can delete the index of function, a very useful function from arrays prototype. The interpreter will very nicely say, return true, all is well. And using that function is going to result in a type error. So one of the many things that you encounter on a daily basis as a developer of third-party JavaScript. So back to Minicom. With this stuff in mind, we need install instructions. We need a way for our customer, Acme Corp, to install Minicom on their site. So the sort of the first take of that might be telling them to include the script on their page. This is going to work. This will result in Minicom.js and the contents of that file getting executed on their page. This is all great. But what we've introduced here is a single point of failure in that if for some reason our CDN isn't reachable, firewall has blocked it or it's down, or if for some reason Minicom.js is slow, what the browser will do when it encounters this line is it will actually halt rendering of the page, wait for the request to fetch this resource to complete. When that is completed, it will continue. So that's kind of worst case scenario for us is kind of impacting the performance or reliability of the parent page in some way. So try to avoid these kind of situations at all costs. So one thing that we might do is introduce the async keyword here, which instructs the browser to not halt for the request to fetch this thing to complete, to continue loading the page immediately, which is great. It works really nicely, except it's not supported on older browsers. So we need to do something like this, which you're probably familiar with. And this is the Google Analytics install snippet. So basically what this just does, so self-executing function, it creates a script element and dynamically inserts that script element into the DOM. And ultimately what this does is gets our script into the page without blocking the loading of the page. So now that we have a mechanism by which we can load our JavaScript on the page, let's write Minicom. So what are we going to do? We're going to add a contact us link into the page somewhere. So in order for us to augment the DOM in some way, we need to wait for the DOM to load. And my first instinct whenever I need to wait for the DOM to load before I can do something is to introduce jQuery and use jQuery's really handy onReady handler to defer this setup code until the DOM is actually ready. So this introduces some interesting questions as a third-party JavaScript developer. The first of which is, well, putting aside the question of is jQuery an appropriate dependency to be pulling in as a third-party library, let's forget about that and just pretend that it is for the moment. Where does jQuery come from? We could ask Acme Corp to include jQuery for us, a specific version of jQuery. That's not a really great developer experience. We could assume that it's there. That's probably not safe, or maybe it is, I don't know. Let's pretend it's not. So I think ultimately what we need to do is include jQuery and any other dependencies that we might have ourselves. And so this is one of the ways in which JavaScript development and tooling has improved a great deal in the last couple of years. Let's introduce a module loader. So this really handy require call here allows us, when we're using something like Browserify or Webpack or a myriad of other tools, to take our code and its dependencies and produce some a bundle of that code and dependencies that we can redistribute. So now that we have a mechanism to distribute our code with its dependencies, there's actually one more gotcha to jQuery and a couple of other libraries that like to clobber a global window.something variable. You, as a consumer of jQuery, as a third-party JavaScript developer, if you want to tell jQuery to not, or if you want jQuery to run alongside some other version of jQuery that might already be on the host page, and this no conflict function here is handy. So a little bit more. So I've just filled out our ready handler here. So all we're doing is using jQuery to construct an A element. We're applying a click handler to that element. The click handler will do nothing but trigger an alert. And then we're just appending that element to the body. And so this is it. So the contact us link over here has been added to the page, and if I click on it, yay. So we want to do a little bit more than that. This is the event handler for the click call. So instead of triggering an alert, which isn't all that useful, we're going to create a div element, and we're going to use the inner HTML attribute here to create this welcome message of sorts. So we've got our header, we've got a call to action, a text area, a button, and we're just going to append that to the body. And so this time we have this. So that's great, but somehow we are subject to the crazy design decisions that the developer of acmecorp.com has made, and our developers, our designers aren't very happy about their design ending up with Comic Sans. So they've asked us to do something about that. So we need to delve into the world of CSS, or cascading style sheets. So I'm assuming there's some level of familiarity with CSS in the room. So, I mean, ultimately what's happening here is a rule on the parent page here in bootstrap.css is cascading through the DOM as you would expect it to, and because we're just another element in the DOM, that rule cascades through our markup and is applied to our headers and other elements. So what can we do about this? So we've got a couple of options. The crudest of which, and probably the most workable, is what we refer to as the CSS reset. Ultimately what this sort of boils down to is writing your CSS in such a way that it targets your elements in a very specific manner and makes liberal use of the important keyword so that it's hard for styles in the host page to leak through to your own elements. This works remarkably well, but it's kind of a painful way to write CSS. This is actually the approach that we took with the intercom messenger. And yeah, it's worked out pretty well, but we're, an alternative is to use an iframe. So iframes are, I think, I don't know how many years old, but came about in the version 4 spec, HTML spec. So been around a long time. They're enormously powerful, and one of the aspects of the iframe is that they give you that isolation, both in terms of the JavaScript execution environment, but also in terms of styles. There are drawbacks to using iframes, though. They're not very flexible in terms of how they allow you to communicate across boundaries, so from the parent page into an iframe and vice versa. It's actually incredibly difficult to do in a way that's, it's sort of backwards compatible to old browsers. They have some constraints that they introduce around kind of more advanced styling techniques that you might want to use, like transparency and blur, things like that. So for those reasons, we decided against using an iframe for the intercom messenger. Another alternative is the Shadow DOM. So the Shadow DOM is a very recent spec, very recent spec. Produced by Google, I think, as part of the web components sort of umbrella of specs. And the Shadow DOM, it allows you to do a bunch of different things, but there's one specific aspect of the Shadow DOM that is potentially useful to us. And so this is it's a method of establishing and maintaining functional boundaries between DOM trees and how these trees interact with each other within a document, thus enabling better functional encapsulation within the DOM. So ultimately, the Shadow DOM and the web component specs are kind of coming about to help us write better components for the web, better UI components for the web. But one aspect of the Shadow DOM that we can use is it allows you to minimize or reduce the way in which the ancestors of an element and how those ancestors are styled will result in leakage of styles into your element. So this is how it works. So this is our open widget callback again. It's almost exactly the same as the previous one, with a few extra lines. So this is the key function here. We create a host element, which is just a standard div, and we call this new create shadow root function on that element, which tells the browser that this point in the div tree is a shadow root, and it should diverge in terms of how it is styled from the parent. And there's a slight, or there's an addition of some styles here, and this Shadow DOM-specific pseudo selector, which is the host, and just allows us to apply our own styling to the host element. So this is what this looks like. So no more Comic Sans. And when I inspect these elements, we can see that or hopefully you can see that it's the browser style sheet is the style sheet that's impacting or affecting these elements. So that's great. We are no longer subject to the crazy whims of this designer. So I'm going to cheat a little bit and move one step further, which will get us to here. So looking a little bit more like a messaging widget that you can type in here and click send, but when you click send, nothing happens. So what is the next step? HTTP. So we want to take that input that the user has given us and we want to transmit it to the server in such a way that it can be processed on the server and result in notification emails or push notifications or whatever. We're not going to worry about that side of things, but we are going to worry about that HTTP request to get the data to the server. So when we're talking about, and we want to do this in an asynchronous manner so that where that data is, that request flies off in the background and we can update the UI in some way that indicates to the user that this feedback has been submitted. So what we're talking about here is AJAX and the XML HTTP request. So we might do something like this, just using jQuery's handy post function to post our message to our messages endpoint. And if we did this, by default, we're going to end up with this error message. So cannot load this endpoint, origin acme.industries is not allowed. And so what we've fallen foul of here is the same origin policy. So the same origin policy is this: a web browser permits scripts contained in a first web page to access data in a second page, but only if both web pages have the same origin, where origin in this case is really just the domain. So because these domains don't match, the same origin policy, which is a security mechanism, kicks in and prevents the request. So we need some way as a widget that runs on third-party sites to be able to, make these requests to our API servers. So we need to sort of circumvent the same, well, maybe not circumvent, but we need to deal with the same origin policy somehow. And a perfectly workable way to do this is via JSONP, which is kind of a wonderful hack, which ultimately results in you not requesting, excuse me, results in you requesting JavaScript from the remote server, injecting that JavaScript into the DOM with a script tag, and having a callback handler ready and waiting to receive the data. That works remarkably well and has for a long time, but there is a more modern way of getting around or dealing with the same origin policy, and that is CORS, which stands for Cross-Origin Resource Sharing. And what that allows you to do is, on the server side, supply a response header. There are actually a couple of headers, but this is sort of the most important one, which allows you to specify which origins are allowed to make requests of this server. And you can specify one or more actual origins here, or you can specify star for all. What that gets us is the ability to make a cross-browser request. That was completely fake. There's no server running in the background, but that's roughly how it would work. So that's kind of it. Sort of a contrived example, but these were actual issues that we encountered during the development of the in-app messenger, and we actually solved some of these issues in the same way, in that we used the CSS reset, we used JSONP when necessary, we use CORS when possible. Yeah, that's it. And we're hiring. Questions? Or any questions?
You said you use JSONP
Older browsers. So when is when is CORS not usable? Older browsers. So we can detect that the browser doesn't support CORS and fall back to JSONP. Or in some cases, you actually have to allow the request to fail and then fall back. But generally, you can reliably detect that CORS will or won't be possible.
Okay, and then you didn't just JSONP the whole time. Is the cross-origin better, or?
JSONP is very workable, but it makes some things harder, like caching, because you have to supply a callback as a parameter to the endpoint. It kind of complicates things like caching. Generally, CORS allows you to kind of work with the browser instead of against it, and it's more pleasant. So the Shadow DOM is only currently supported by Chrome Canary and I think Safari. So it's like, it's very new. So we detected it by signing up for their web application and trawling through their source and looking at errors and whatnot. So it's actually possible to detect when a function has been deleted or when a function has been replaced with a non-native function. So we do have a suite of are parts of the standard library that we rely on that we can check if they're present or if they're present and have been redefined. And if that's the case, then we provide our own, which is kind of painful but necessary.
What about?
Oh, what was that?
What sockets?
So as of about 3 or 4 weeks ago, the messenger is actually real-time, so it behaves like a typical real-time messenger client, and we do that using WebSockets. So we use a mix of both WebSockets for kind of real-time stuff and sort of HTTP for non.
And in terms of the maintainer of the website that's being plugged into, what's the process for them? Because you mentioned web components and Polymer as well, which is Google's thing pioneering that, and it's a bit like Angular that we can like declare our markup, and that can be loaded with all of this logic. So how does that change? Like, do you see yourself doing that soon, where you would be incorporating that, or like what is the process at the moment for people who want this on their sites?
So the process right now is very kind of 2009 in that it's you don't have that level of control. You include the snippet, which includes the script, and there's a sort of a configuration block, which is a JavaScript object that if it exists in the DOM, we will read and use, and that allows some configuration. But I don't know if this, this isn't on our short-term roadmap, but one of the things that we want to look at doing is providing increased customization control, and I think web components will probably play a big part in that, or I hope they will. Cool.
Thanks very much, Paul.